VR. It's awesome that everyone can make it. How do you progress? Yeah. So just wanted to, up the top, thank a lot of people. It was maybe a month ago, Linz and I were having a beer going, there's VR meetings and AR meetings and MR meetings and all kinds of things, and there's no web VR ones. Lindsay tweeted, and before we knew it, all of you enthusiastic people, John and Mark especially, went, yeah, you should totally do it, and then it just kind of happened. So thanks a lot for Mark and Rob for coming out to talk and giving this event some substance. John and the guys at Web Directions, this isn't our office. Web Directions are hosting this for us along with all the drinks, just because they're awesome, so thank you.
You're very welcome.
Boomworks have helped. There'll be a 360 video on after this we'll upload. There'll be this guy downstairs helping everybody into the building. There's all kinds of stuff Boomworks are helping with as well, so thanks. And we weren't expecting this many people, so thanks a lot for coming along. So what we're going to do tonight is the bit that I'm doing now, and then after I've finished doing the thing that I'm doing now, which is the intro, Linz is going to basically introduce Web VR as a high level and how it kind of differs from, you know, conventional native VR and why it's so great. Rob's going to talk, then we'll take a quick break, give everybody a chance to get a fresh beer, use the facilities, whatever you want to do. We'll then come back. Mark will have a talk. We'll then go through some events that are coming up, and then we'll wrap things up and you guys can have a chance to mingle again. So, Vince, you want to talk about some things?
Sure. So, what is Web VR? It's virtual reality on the web. It's about as simple as you can make it. Just a bit of a disclaimer, Danny had nothing to do with the following slides.
What did you do to the slides?
So there might be some rough edges. Virtual reality has been around for a fairly long time. It's just sort of been around the 50s and some very funky stuff. It's mainly been fairly niche, used for gaming and simulations and things of that nature. Required fairly expensive hardware, it was difficult to develop content for it. Recently we've seen a literal explosion of hardware. The first explosion, I should say. There's new headsets from Oculus and like that. And all of the stuff that's coming out now is capable of rendering fairly complex 3D scenes, as well as having controllers and sensors to make virtual reality become a real reality. Also been a number of tools created recently that make the creation of content and applications a lot easier for novices to get into. Well, they still require some degree of programming and 3D modeling knowledge, so they're not quite as simple as they could be. We've also got the web, which has been around for a couple of decades now. Although it's strange to think about it, I got into it in the early days, that it would still be hanging around and be making a living off it. And it's been wildly successful. Big part of that has been the underlying technology has been free, open and accessible to all. And we've also developed all kinds of tools and processes so that we can effectively build for the web, efficiently build for the website. The basics are still accessible so that anyone can come along, type in a few HTML tags, and they're off and running a bit of a web page. So the convergence of VR and the web has also been slowly happening for the past 20 years or so.
23, but who's 20?
23. From the VRML in the mid-90s, which Mark here is the co-creator, through to the present day when we've got the ongoing development of a number of APIs such as WebGL for displaying 3D graphics in the browser, WebVR API for providing access to VR devices themselves. There's also been fairly wide adoption of WebGL by major browser vendors. The WebVR API is still in draft form, but it's already supported in experimental builds of quite a few browsers. Hopefully the others will get on board pretty soon. And there are also a number of frameworks built around these technologies to Free.js, A-Frame, React VR, all them. Yeah, they just make it even easier to get started with VR on the web, which Mark will be showing some examples of in a moment. The future with VR on the web, the hardware continues to get better and faster as new product announcements seem to come pretty much every week, so there's a lot of investment in there from the big companies. Browsers continuing to support more and more of the features needed for WebVR, so it's another big part of it. The W3C, which is the body responsible for developing standards for the web, is actively working on making the web a better platform for VR as well. So there's a lot of consensus around how it should all be implemented. We'll also need to find ways of implementing things that we currently take for granted on the traditional web, such as SEO, performance, accessibility, things like that we've pretty much nailed down these days, but putting those into a virtual space is going to be a bit of a challenge. There are also brand new challenges to web practitioners, such as dealing with motion sickness that we've never had to do before. So there's probably a lot we can learn from the traditional VR in that case, where they've been through this stuff in games and other mediums, and hopefully figured out some ways of dealing with that sort of stuff. So, in conclusion, pretty excited about the possibilities with VR on the web, and look forward to getting in there and doing it. And I'm also excited about virtual goats. That's probably it. Any questions for anyone?
I do. So out of that three frameworks, Three.js, React, and A-Frame,
Yep.
what's the which one has the least steep learning curve? The easiest one to learn?
Probably A-Frame, I'd say.
right?
Yeah. Those were just examples, but yeah, A-Frame is very simple. It's basically the same as writing a bunch of HTML tags and you get a web page. You write a bunch of tags and you get VR. So sure Mark will show us how easy it is.
What can be done?
What can? Pretty much anything is possible. Imagination is the only limit there. There's the obvious ones like gaming. That's pretty well established in traditional VR. Things like data visualization, mapping, some other possibilities. There's probably all sorts of wacky ones like around finance. I'm sure we could watch films in VR one day there. Still going to the cinemas.
Is there many advantages to doing, say, Wes VR over building and deploying something like Unity? And what's the options there?
Some of the the ease of getting into it, things like rapid development of the big ones, having a very open ecosystem where you don't have to go to an app store and download stuff and update it. That's the other big drawback there.
Lindsay, if I can, there's another thing. Unity apps tend to be their own universes. They're completely self-contained. Try to integrate a real-time data stream with the Unity app. It's not easy to do that. All right. Whereas with the web, you just pull in a component, you some of that's going to be driven by what you're actually trying to deliver in terms of an experience.
Do you think Unity will start to go the way of web?
Well, exciting news yesterday was Tony Breezy, who's Mike's co-creator of VRML, has joined Unity as...
He's the head of VR and AR strategy now.
He's a fairly good provider of VR and web stuff as well, so hopefully there'll be some new exciting things coming out of Unity in the future.
Yeah, compare with what we can do. The other question is what we can't do with what we are at this moment. I believe it can do everything in the future, but what's the current limitation?
I think the biggest sort of constraints we have now are the hardware not being as fast as it could be. So frame rates, I think the Gear VR was circulating before, and we were looking at that. It's one of the least sort of impressive experiences there with frame rates. And I think it runs at 60, doesn't it?
No, that's part of the
It should
issue.
be 90, right? Right now,
can
like that's high as 90 now on the A frame with the latest updates.
Yeah, but so Google have announced the Pixel phone recently, which is pretty much built for VR, so that would definitely be a good one, and the other device manufacturers will follow suit because the device is capable of those sorts of frame rates and the same sort of experience. So yes, yeah. So ready for
Hey everybody. Great turnout. Awesome. So I just wanted to talk through, give an overview of the W3C workshop that I just attended in San Francisco, and also talk a little bit about the platform that we've just launched and how the two are related, and also an overview of what I was evangelizing around where we're at the moment with WebVR and mixed reality in general. So this is the platform that we've recently launched. About 2009 we launched Build AR, which was the first web-based AR content creation tool. And since then we've been really focused on bringing the web standards up to a level where they can support mixed reality in general. So 2010 I was pitching this sort of thing at different SANS events, and it was probably a chemical problem back then. It was insane to be thinking about those sort of things, but now the mainstream's really caught up with that. I also co-edit a spec called the Media Capture Depth Extension, which is bringing depth sensors, so like Tango and HoloLens, those sorts of things, and making them available through the web API. So I'll talk a little bit about that as well. But what seemed to happen last month is insane. Everything coincided. We called it October. It just seemed everything was launched then. So PlayStation launched their VR platform. Oculus's large event and the touch controllers are released, and they've jumped on board. So with Carmel and their own WebVR support, so it's great to see people finally getting WebVR religion. And then obviously Google releasing Pixel and the Daydream as well. So it's an amazing time, and there's really a lot of momentum now. Things are really moving along. So we think it's a perfect time to take stock of where we're at. WebVR itself is only about 2 years old, and it's a really important time to think about the structures that we're creating now and how that's likely to change in the short term. So it's worth stepping back and looking at mixed reality. This is Milgram's mixed reality continuum. So on this side you've got the real world environment, the sort of meaty flesh space that we're in, and on the far side you've got the virtual environment. So that's completely immersive artificial experience. Here you've got augmented reality, so that's overlaying digital content onto your experience of the real world. And then the other side, the augmented virtuality, horrible word that nobody ever really uses, but it's pretty much things like projecting real feeds, so video or sensor data, into a virtual experience. And it's quite a fuzzy term. People tend to move around and use different definitions. Some people even use mixed reality as one of these points on the continuum. The whole point about it is it's really an artificial construct. There's no way to experience any of those without being in this environment. So everything you experience goes through and is mediated by your brain and your senses. And we trace this history back a long way. So you look at the stereoscope sort of vision. This is from 1905, I think. People were, craving these sort of immersive experiences, alternate realities back then. 62, Morton Healy created Sensorama. So he was a filmmaker, and he created a virtual motorbike tour through Manhattan. You can see his son's still trying to sell it off. I think it's a great piece of history. So let's all whip around and we can buy it. $1.5 million pretty expensive. But you sat on the experience. It vibrated like a real bike. It pumped smoke and smells through. Played film of driving through Manhattan. So that was a pretty visionary thing to create back in 1962. 68, Ivan Sutherland created the Sword of Damocles. So basically this was the head tracking system over your head. That's why they called it the Sword of Damocles. Now that's pretty much replaced by an IMU. It's amazing how far we've come, but it was really the first immersive head-mounted display of a digital nature at least. And then you can trace Tom Furness's work. So he was working with the US Air Force and focused on how you can deliver situational awareness to fighter pilots. And so he started with these monocular experiences, really looking at how you could bring the multiple computer displays and information up into the pilots, and they really found that was overwhelming them even more. Just making it more present didn't make it better. And traced it right through to this sort of virtual landscape experience that they created, where it was really about seamless situational awareness, taking away, stripping the overwhelming information and just focusing on salient points, giving you a real superpower of focus. And so he went on to found Hit Labs, and I'd really recommend looking at some of his research. He's an amazing researcher. So VR hit our zeitgeist in the 80s. We all had one of these, didn't we? There was the Nintendo Power Glove and Jerome Lanier, people like that were really promoting this, new technology and really caught the mainstream attention of media as well. But I think if you tried it back then, this was pretty much the experience most people had. It was more of a Halloween experience. The pixels were about this far apart. It was great. You could drive a bus through them. The tracking was terrible. The content was pretty poor. It was just way too early. And so if you look at how technology spreads, innovation spreads, everybody's probably familiar with the bell curve. So you've got the innovators, the early adopters, through to the laggards. And this is really the number of them. There's a much smaller number of people than the innovators. But it's the S-curve. So once you unfold this and the market grows over time as they all come into the market, it's an S. And that's what we're all trying to do is build up this wave in the S. But the way human expectation works is more of a straight line. So in the beginning we have this linear expectation. It's all going to be fantastic. This is an amazing world that we're going to be building. But the technology really underperforms and we overpredict the change and we're all dissatisfied and we're all unhappy. And then over time people forget about it, pass on. The technology keeps increasing and it's getting better and better, but our linear expectation is still the same. And now we're in the situation where we are now. Another wave comes through. The revolution's finally here, and things are really changing. And I think that's the point that we're at the moment.
Where are we in that graph? Sorry.
I think we're kind of about here. It's still a huge, exciting hump to go. Everyone loves a good hump. So 2012 VR was really born with the Rift launch on Kickstarter. It's amazing the support they got. The timing was there with the IMUs being performant now, the availability of crowdfunding. And since then, everybody's aware of, obviously that's why everybody's here tonight. I find this photo so disturbing. I don't know about you guys. I think it says a lot about our future. But you also notice, nobody's wearing headphones in this experience. I think audio is 50%. There's a lot of discussion of that at the workshop. Web audio is amazing. We'll talk about that in a little bit. But there's a huge huge opportunity there. Then in 2009, AR really hit the mainstream perception. If you look at the Google Trends searches, it's about the time when the first searches really started peaking. The AR toolkit that this is based on was launched about 1999. Building has some Cato, but it was a compilable C application. You know, people would build it for their own machine. It was a very small installed base. Very few people ever tried it. It was ported to Java, and then that was ported to Flash. So this developer, Sakusha, he developed this in 2009, and that's when it really started hitting people's attention, because you could load a web page and have this experience. But you had to print out markers and have all the content, and still most people experienced it through YouTube rather than actually trying it themselves. So really, you know, the public wasn't ready for this sort of experience. From then, the mobile space evolved. The Android G1 was released. That was the first device with accelerometer and GPS. So then Wikitube launched their first mobile AR browser. It was location only, but it was a major step forward. Then Leia and Matteo, those sort of people evolved, and we brought computer vision into the mobile space. It started off as marker tracking like AR Toolkit, but then quickly moved to natural feature tracking, so you could just track any sort of image. And then SLAM, so simultaneous localization and mapping. So it would actually build a map of the environment as you're moving around. And that's really the state of the art where computer vision and tracking is at the moment. But that died off and really didn't make the mainstream again until this year, and everybody here is definitely familiar with that. It really grabbed everybody's attention, but if you look at the technology in it, it's really simple geolocation-based AR, and a lot of people would switch off the camera, so really it was, you know, spatially located VR. And like I said, last month was October, so really we've hit a critical point in time. But the problem that we've found, we've been doing this for a long time, there can be something like 27 steps from knowing there's an experience somewhere around you or near you or in some related to something you have, to actually getting the application and using it. And at each of those points there's a massive drop-off rate. 27 steps is horrendous. So we really believe that the web is the answer for that. It's the most direct medium for sharing content. And if you look at the standards that are supported, so Lindsay went through this, you know, WebGL is an amazing standard now. It's ubiquitous on web browsers. The performance is great, but the thing that WebGL has also delivered us is it's allowed us to access the array buffer. And the array buffer gives us access to raw pixels within different streams. So now when you have the camera access, and I'll talk about that in a second, we're not just taking a video element and plonking it on a page and going play. We can actually reach into each of the frames, introspect them, process the pixels in real time, and do real analysis of computer vision. Orientation and tracking. So initially device orientation is the API that works on the unwearable web. And WebVR brings that up to modern speed, so a higher frame rate, and the dedicated head-mounted displays definitely do this much, much better than these sort of consumer mobile devices. But you can't underestimate that. Actually, while I've got this in my hand, the head-mounted displays are great, and it's a, you know, a great experience for people to pour themselves into. You can't underrate the unwearable experience of people just creating virtual reality and those sorts of things on flat screens, but then also the cardboard experience. And now you have these sorts of wearable displays, or nearable displays. That's $11 off Amazon. It's always in your pocket. Sometimes there's a real benefit to just portability and usability over performance. 3D audio. So web audio is an amazing API that allows time-accurate slicing of sound-based media. And Google are doing some great work pushing this ahead. An implementation based on web audio, it's an area called ambisonics, and it delivers even more realistic 3D sound. But it's still just working on top of the web audio platform. And so I'll talk a little bit about in the platform that we've released, but you can just attach a sound to an object, place it in the space, and it'll sound like it's coming from there. It's awesome. Camera access. So with WebRTC, it allows us to open the sensors on these devices and access the raw streams. And like I said, the pixels and the sound waveforms. So there's an example from probably 2 years ago now, where we have fast feature detection running inside a camera. So the JavaScript processing every pixel and every frame, looking for corner features